Good morning, and here we are on Wednesday, 4/15/20. Actually, we're not, but we are recording, and it's QBUS-110. And today I'm going to finish Section 11.5, which ends the differentiation part of the course. And I'm going to complete something that we had started working on last time. We're doing what's called a market equilibrium problem, where we have a demand function given by PD that is 900 minus 2Q minus 1/2 Q squared, and a supply function, P of S, is 200 plus 10Q. Now, P is the dollars per unit, and Q are either the number of units made, demanded, or sold. Now, we're talking about adding a tax here. We're going to add a tax on a supplier, and T is the tax dollars per unit. Why are we adding little t, dollars per unit? Because P itself is in dollars per unit. So in order to keep the units consistent, I have to do this. So basically, I'm going to add a T to the supplier side because the tax comes on the supplier made. Now the supplier is going to add it on to the price and pass it off to the consumer. So when I add to equation 2, I add T, the supplier is passing it off to the consumer. Now, if you remember from QBUS-100 and market equilibrium, the price demanded equals the price of the supplier. That's when they equal each other. So let me take the equations, equation 2, equation 1, and make it equal to equation 3. So here I'm making equation 1 equal to equation 3. So you get 900 minus 2Q plus 1/2 Q squared equals 200 plus 10Q plus T. Now, we're not interested in little t, really. We're interested in the total tax revenue to the IRS would be the price. That's going to be the little t. Sorry about that. It's going to be the tax per unit times the number of units. That would be the total tax revenue given to the IRS. Now, what's our goal? Our goal is to find a number of units that maximizes the tax revenue to the IRS. So this sounds like a derivative problem. So I'm going to erase everything but this guy over here. And we'll finish this. Okay, I'm going to solve 4 for T. I'm not going to go through the gory details. You should know how to manipulate these now. So T is going to be, actually I'm not. What I'm going to do first is, sorry, I'm going to multiply equation 4 by, but I want TQ, so let me do that again. Let me solve it for T first. I'm sorry, I'm sort of mixing you up here, but let's solve 4 for T. That's the easy way. I could do it the other way too, but so let's solve 4 for T. So T is going to be equal to 700 minus 30Q minus 1/3 Q squared. But as I said before, I'm not interested in T. I'm little t, the tax per unit. I'm interested in T, so I have to multiply both sides by Q. So now T is going to be equal to TQ. And I'm going to get a 700Q minus 30Q squared minus 1/3 Q to the third. And that becomes my tax revenue equation. Okay, 700Q minus 30Q squared. Now I want to maximize T. So I'm going to take the derivative of T with respect to Q. Call that T prime Q if you want. And that's going to be 700 minus 60q minus q squared. Okay, 3 times 1/3 is 1. All right, so we have 700 minus 60q minus q squared. Sorry, that's squared. Now we want to make that equal to 0. Well, what I can do is I can actually, since I don't like leading negatives, I can multiply both sides by minus 1. So I'm going to take minus 1, 700 minus 60q minus q squared equals, of course, minus 1 times 0 is still 0. And now it's time to get rid of these guys. There'll be plenty of room, I hope. And this is going to give me q squared plus 60q minus 700 equals 0. Now what I can do with this now is I can just do a reverse FOIL. And you're going to get Q, and you're going to get the 70 and 10. And of course, you want to put the plus here, the minus here, then the plus 70 minus the 10 cubed gives you 60q, and minus 10 gives you minus. Solving this, q minus 10 equals 0, q equals 10, q plus 70 equals 0, q equals minus 70. It doesn't make physical sense to have negative units, so we're going to throw that out, and our answer is going to be q equals 10. Now that just tells me this is a critical point. Remember, I found a critical point now, but I don't know whether that point is a max or a minimum. Well, the one way to do that is to take the second derivative. So I'm going to take the second derivative, which is the derivative of the first derivative. So the first derivative, t prime q, equals 700 minus 60q minus q squared. So the second derivative, using the power rule, is going to be minus 60, that's a square here, minus 2q. All right, now, how do I figure out whether, well, I just substitute what q is equal to. Okay, so have we found a value for q? Yes, we have. We found a critical point, q equals 10. So I'm looking to see what the second derivative will be at q equals 10. So double prime 10 is going to equal minus 60 minus 2 times 10. And I already know it's going to be negative, minus 80. And when the second derivative is negative, less than 0, that means I'm at a maximum point. So q is a maximum. So let's figure out what my revenue is going to be at that maximum. Once again, let's erase this. And I know that at max, t, q equals 10. I know that t equals tq, but the equation for t is what? We got to go back to the beginning equation, which was 700q minus 30q squared minus 1/3 q third. And I'm going to substitute t, q equals 10 here. 700 times 10 minus 30, 10 squared minus 1/3, 10 to the cubed. And getting rid of all the funny stuff, we get $367, $3,667 to the IRS, passed off to the consumer at market equilibrium. How many minutes we have?
Oh, sorry. A little over 4.
Okay, for this one?
Yeah.
All right, so let's see what tax does to our graphs. If you remember from QBUS-110, which you probably don't, we have an equilibrium graph. So let's do a graph here and see what the graphical. Let's do a graphical analysis. So let's do a Q and a P. All right, so we're going to have this, all right, which is your original supply function. No, I'm sorry, that's your demand function. This was your original demand function. Your original supply function, supply without tax. All right. Then I go here, and this is my supply function with tax. So if we go back to my demand function, let's go back to what our demand functions and original supply functions were. Go back to the beginning here. Supply without tax was P equals 200 plus 10Q. Supply with tax is P equals 200 plus 10Q plus T. And demand was equal to P equals 900 minus 2Q minus 1/2 Q squared. So we got a demand function, and we got a supply. Now here's our market equilibrium. When demand equals supply, so this would be the number of units, let's call that 1, at market equilibrium without taxes. And this would be the number of units with taxes. So what does taxes do? Let's look at it. And this is the price. This is P1 without taxes. And this is P2 with taxes. So what has the what has the IRS done? Well, it's moved from here, market equilibrium point, ME point. It's moved from here to here. Well, what happens is it's forced production to go down and price to go up. That's why a tax break, when the government passes it, stimulates the economy. We go from here to here. When you take more taxes, you decrease the number you produce, decrease jobs, decrease employment, and increase taxes. But anyway, that shows you this is a good example of why we like to have a tax break or a bill which decreases taxes as a stimulus to the economy. This says it right over here. All right, well, as we finish this first 15 minutes, we are now finished with Section 11.5. There will not be a problem on taxes on your next test, number 2. If there is one, it'll be a bonus. Okay, but now we're going to go into the next part of our course, integration, or sometimes called anti-differentiation. See you in a few.